Hi everyone, in this video I'm going to show you what is the antiderivative or indefinite integral and what's the graphical interpretation. First, the question, what is it? So that's a good question, and to show you what is the antiderivative, we're going to start by remembering or look at the topic. You remember the word derivative of a function, so the antiderivative sounds like the opposite of the derivative, and that's exactly what it is, the opposite. So last semester we gave you the function and we asked you for the derivative. We had many notations for the derivative, the most used were the f prime of x, which equals differential of y over differential of x. We have already talked about and studied about the meaning of the differential of y and the differential of x, and we will continue using those notations. So I'm going to start the explanation with a very simple example. Let's think of the derivative of x as 2x. So, in this case, what would be the function which derivative equals to x? If you remember, we used to multiply by the exponent of the function and then to subtract 1 to that exponent. So, if you look at this, the derivative of x squared equals 2x. So, in this semester, we're going to work with the derivative, this one, and you're going to find the antiderivative. But it's simple, yes, it's as simple as this, that's the definition. But now we have to think of another thing. What if f of x, instead of being only f of x, was x squared plus 1? Its derivative is 2x. And also, it could be that f of x was x squared minus 3. So, for the derivative of x squared minus 3 equals 2x 2. And we can have so many functions, an infinite number of functions which derivative equals f of x. Look at another example. Which derivative equals 2x. So this is why it is called the indefinite integral, because there are many functions which derivative could be 2x. So let's explain how are we going to write this. So all functions with the form x squared plus c are the antiderivative of the function, that derivative 2x. So this c is an arbitrary constant. It could be any real number because the derivative of a constant equals 0. So this is a family of functions. So graphically, the antiderivative of a function is a family of functions. So I'm going to show you a family of functions for this antiderivative. Well, we found that the derivative equals 2x corresponds to the function f of x equals x squared plus c, because the derivative of a constant is always 0. So we found that the antiderivative, it is called the indefinite integral because we don't know exactly what is the function. So we know that it is x squared, but we have to add some constant. So I'm going to show you with a graph why we call this indefinite integral a family of functions. Well, take a look at the graph. All these parabolas have the form x squared plus c. All of them, x squared plus c. If c equals -3, then we would be talking about this function. If c equals -1, that will be this green parabola. If c equals +2, will be this purple parabola. And if c equals 0, that will be this red parabola. So as you can see, this is why it is called a family of functions and indefinite integral. Now we're going to talk about the mathematic notation. Let's begin by writing the differential as the definition. Differential of y equals f prime of x times differential of x. Then we write the sign integral before both members. That means that we're doing the same operation on both sides of this equation. So we're going to write the integral of dy equals the integral of f prime of x times differential of x. The integral sign is a very simple symbol. It only indicates when we're looking for a function whose derivative is the expression wrote after the symbol. This expression is named the integrand. Well, now that we know what is the symbol that we're going to use for this antiderivative operation, which is the opposite of the integral, we know we have to use this symbol, the integral. The integral of the left side means we're finding the function y, and the integral of the the integral of the right side means we're looking for the function whose derivative equals x cubed. So for this example, we found that the integral of the differential of y equals y. That's the function we're looking for. And on the right side of the equation, we found that the derivative for x to the 4th power over 4 plus a constant equals x cubed. So this is an example of the function whose derivative equals x cubed. But I'm going to show you now the elements of these equations. Now the elements of this expression. First, we have the symbol for the antiderivative or indefinite integral, which is here, this symbol. And then is the integral sign. Then we have the integrand, which is x cubed times dx. Then its variable of integration is x. In the first member, because its differential is differential of y, will be y. And the second member is x 4 over 4 plus c, because its derivative with respect of x is x cubed. So its differential is x cubed. As the differential of any constant is 0, we must add c in order to include all the family of functions whose differential can be x cubed times dx. So we won't be guessing what could be the function whose derivative is given. So in the next video, I'm going to show you the rules of integration.